So by its definition, enumeration is just a set of named constants. So let's take a look. The syntax is very, very simple, and it's kind of similar to very similar to a class. So you can see that an enumeration here named shipping type says these are the shipping options, and the shipping option could be next day, second day, or ground service, which is like a a regular, perhaps the cheapest type of delivery. Okay, so let's just talk about the shipping types and see perhaps an example of it in the code. So if I have my customized validator environment here, I can go to the package and I can say new, and I think that on this list, let's see if I can create another. I'll just say just so that I have a space for it, I'll just say create new Java class, right? And I have, to be consistent with the slide, I'll say shipping type or shipping options. So this will be shipping type, which I create. And over here, instead of naming it a class, instead I will make this an enumeration, just like this sample demonstrates. An enumeration shipping type, and of course I need to provide, and we can just copy and paste the set of constants from here. Okay, so here's the set of constants. The convention is that you actually specify them basically in a vertical manner instead of any kind of horizontal. Just make them list like this. What this creates, what this shipping type really creates, and what it adds to my project, is that I can go now to my main app someplace, right? Go to my main method, and what I could do is I could now declare an integer like constant, like shipping type, right? Shipping type, and I'll say type equals, and the difference between the enumeration and a class is that enumerations are constants which are known at compile time, and they're compile time only facility, and therefore you don't have to say new, right? So it would be a mistake to say new something. Instead, you just say shipping type, shipping type, and you select one of the constants, right? So we'll just pick maybe UPS ground, right? So this becomes a type, and if you want to make a comparison, for instance, if you want to say if this type equals a specific shipping type later on in your code, shipping type dot second day, right, which is not what we have been initializing our type with, but I can do other things with respect to that. You have to provide a name constant. So this syntax enforces the use of enumeration as a name constant. Remember, we could have what we could have done. Instead of making this an enumeration, we could have made this a class, right? And we could have declared this static int, maybe even say final static int UPS next day, and assign it some value like 0, for instance, right? And likewise, we could make this final static int UPS second day and make it unique and make it 1. And likewise do this with UPS ground, and UPS ground would be constant too. Then if I switch over to my sample where I'm trying to use this code, right, what I can do is if I actually make those public, right, public and public, this will be, my client code is going to be exactly the same. If I save everything, hopefully my code will compile just fine, except that of course the shipping type no longer is the shipping type. I need to declare it as an integer. And this is the weakness of this approach, right? If I make class shipping type, I can declare all kinds of variables in there, including the constant data pieces, which I can initialize and use as name constants. However, in the code, they should perhaps be used as their original type, which is an int. So this int thing makes it a weak type of enforcement of usage of name constants. Although I can still use references to my class members such as UPS ground and UPS second day, but no one would stop me from comparing it to number 2, right? So there's no way to enforce this, right? So I can initialize my type as a name constant, but all of a sudden, for some reason, simply use this constant literal 2 to make a comparison with my current type. So this is not good. So that's why, once again, instead of this approach, we take a different approach and we say, how about this? We make a shipping type an enumeration with the sole purpose to use it as a bag of name constants, right? So we remove these ints and we remove this initialization, and we replace the semicolons with commas, and this is the syntax for declaring an enumeration. So if we do this, by the way, the default value for the first element, for the first item in this enumeration, is going to be 0. So they're still getting their unique numeric values in the enumeration, because enumerations are for integral values. 0, 1, and 2 are the default values for this enumeration. Okay, so if I save this, and if I go back to my main, now I am forced to do this. I can no longer use my type as an integer because I really am forced now to use this specific enumeration type, shipping type, and then which makes it possible to then go and use individual items in that enumeration, which are named items. But also this is no longer possible. Now I have to make sure that I do use the shipping type and pick a specific type out of that list. So let me save this and just make sure that my syntax is all right. All right, so you cannot find symbol UPS ground. Let me see what I didn't do right here. Next day, I accidentally removed UPS ground from my set of constants. Okay, so you can see that this is a stronger type of enforcement of using numeric constants. The only problem here may be with this approach, this is a great approach. It makes the code readable. Everything is very natural. It allows you to not to make too many mistakes with these constants. You say, I want to use a set of constants for my code to make code manageable, better readable, and maintainable, and then you use that as enumeration type. But then the only perhaps limitation here that maybe for some special reasons, maybe you need to change the values 0, 1, and 2, right? So if you're not satisfied with the default ordinal values because in order they're initialized starting with 0 and then basically incremented as we go, then you can customize the ordinal values. At the same time, if you absolutely have to convert to an int, you can say type, right? And you'll realize that with a variable of the enumeration type, which you've created just like an integer, right? You have not just those ordinal values, but you also have access to the methods inside here, and enumerations come with the standard compare to, so that you can essentially sort items based on enumeration values, but you can extract directly the ordinal value, right? So the ordinal value, when you extract them, you can store them as integer, right? So my ordinal value here, I can extract it as an integer, and that's what enumeration internally stores. So you should be confident that when you create an enumeration like this is just a bag of useful contents, but at compile time, those individual pieces actually are based on integer values, and the values are 0 based. 0, 1, 2, 3, 4, 5, depending how many constants you use. And you can even extract the ordinal value. So our next set of topics is going to be how can you customize those enumerated values inside your enumeration type to make it more usable in the code. What other advantages of using named constants can you have in some situations? So we'll go back to our slides, and this just demonstrates creation of a variable of this specific type, but we will take it to the next level